Okay, so Jai Hind to all. Today I am here to deliver the lecture on cloud computing, and basically the topic is selected from the second unit, and the code of this cloud computing is KCS 713. KCS 713. Okay, so in continuation of the first lecture, this is the second lecture, and in this lecture we will cover this virtualization architecture. Okay, because virtualization is a large topic, and basically that is the topic related to the second unit, and that have the many concept like what is virtualization, introduction about virtualization, virtualization architecture, virtualization types, techniques, structures and tools. Okay, so there are the number of topics are related to this virtualization, and here I will cover basically virtualization architecture. Okay, so let us see. So in this particular presentation, we will cover this first one, introduction of virtualization, and the second one is the virtualization architecture. So first of all, we see the what is the virtualization. Okay, so virtualization, as the name suggests, this is a technique, this is a process which create an virtual environment in computing system. So this virtualization create a virtual environment in which the same underlying hardware resources can be shared, can be pooled among number of end users. Okay, so a virtualization machine basically is a software computer like a physical computer, okay, that run an operating systems and applications. The hypervisor serve as a platform for running virtual machines and allow for consolidation of computing resources. So basically this hypervisor, sometimes we give the name of this particular virtualization software as a hypervisor, particularly in the case of type 1 hypervisor, a type 1 virtualization. So basically virtualization is a process in which virtualization software is used, and this virtualization software create an environment and virtual environment in which on the same hardware, on the same host machine, number of different operating system can run at the same time. So this is the beauty of virtualization, that at the same time that allow number of guest operating system to run on the same hardware. Okay, so each virtual machine contains its own virtual or software base hardware, including a virtual CPU, memory, hard disk and network interface card. So this virtualization software basically like this. Suppose there is a hardware, this is the hardware, okay, this is the hardware of host machine. Okay, so on the same hardware, this is the virtualization software, virtualization software, okay, virtualization software. So there is a host, underlying hardware, and on the top of this hardware a virtualization software is installed, okay, and then on virtualization software that allow number of guest operating system to run, number of guest operating system to run, and so on. These are the OS 1, OS 2, OS 3. Okay, this is OS 1, OS 2 and OS 3. So, this virtualization software enable number of operating system to run on the same hardware, okay, and these operating system can deal different set of applications, okay. Applications one are this deal other applications, application and software, this can deal some different applications, okay. So, this virtualization software enable number of different operating system to run on the same hardware, and the beauty of this is all the operating system run concurrently at the same time on the hardware, and these operating system can deal different applications, different software. So, these packages, you know, here OS and application, similarly here other package OS and some different applications, similarly here the other package OS3 and other applications. So, these package is known as VM, virtual machine, VM1, this can be regarded named as VM2 and this can be named as VM3 and so on. That means, by this way we can create number of virtual machine, okay. That means, we can enable different number of operating system to run concurrently, and these operating system represent different virtual machine, okay. So, when we say that this virtual machine, that means the virtual environment of these hardware like suppose there are the CPUs, okay, CPUs are there, hard disk are there, okay, some networking devices are there, like NIC, this is the storage, this is the CPU, so these hardware are given to the different applications through this virtualization software. So, there is a virtual image of these are created for each and every virtual machines, okay. So, basically physically all virtual machines share the same set of hardware, but these hardwares are provided to these virtual machine through this virtualization software, okay. Here hardware, that means a host machine, okay, computing system. So, this computing system also have guest operating system. So, that may be here, okay. This is the host operating system, host OS, okay. This is the host OS. So, this is basically this one, okay. This is the host machine, that may be server which you want to virtualize, okay. So, this have certainly hardware along with their own operating system. So, this is known as the host operating system, okay. That means the machine on which you create the virtualization, that is the host machine, and the operating system of that machine is known as host operating system, and the operating system which are run concurrently on top of this host machine is known as guest operating system. So, these operating systems is known as guest operating system, guest OS, okay. That means, in virtualization we use two kind of operating system, one is the host operating system and other is the guest operating system, okay. Due to guest operating system, number of different virtual machines are created. So, here you can see that creation of virtual machine over existing operating system and hardware. Existing operating system means existing host operating system, and hardware means that host hardware, okay, is known as hardware virtualization. A virtualization machine provides an environment that is logically separated from the underlying hardware. Okay. So, that environment is known as virtual environment, that is separated from this hardware. And who separate this hardware from this virtual environment? This is the virtual environment, you know. This is the virtual environment. This is the virtual environment and this is the physical environment. This is the physical environment. Physical environment. Okay. So, this underlying host is the physical environment and this is the virtual environment. So, the machine on which virtual machine is going to create is known as host machine, and the virtual machine is referred to the guest machine. Okay, because this is the host OS, so this is known as the host machine, and this virtualization software enable different operating system to run concurrently, that is the guest operating system. So, that is why this machine, that is the virtual machine, basically VM, is known as guest machine. Okay, I think it is clear. So basically the virtualization is a process of creating illusion of something like computer hardware, operating system, storage devices and computer network resource, that is the virtualization. Okay. So, this is the process of creating an illusion, that means virtual environment that is physically not exist, physically not exist, different virtual machines not exist physically, that are sharing the same host machine. Okay. So, this create an illusion and we feel that entire host machine is for us, and suppose we are using the host machine through a particular virtual machine and that may be VM1. Similarly, there is the number of virtual machines are there, na? VM1, VM2, VM3, VM4 and so on, and I am accessing that particular host machine through the VM1, but we feel that entire host machine is for me only, that is managed so efficiently. All the hardware resources are managed so efficiently by this particular virtualization layer. So, that is the illusion. Okay. So, virtualization is basically the simulation of the software and or hardware upon which software runs, and this simulated environment is called virtual machine. Okay. And each virtual machine can run its own operating system, that is the guest operating system, and application. Each virtual machine, there is one most important requirement of virtualization is that there are some techniques, standard process in which the developer or the vendor ensure that each virtual machine run in isolation. Okay. So, that is very important, requirement, isolation. Each and every virtual machine run, each and every virtual machine VM run in isolation. This is the beauty of virtualization. Okay. So, there are the number of benefit of this. This virtual machine is more secure. Why more secure? Because each and every virtual machine run in isolation. Suppose this is the VM1, okay, and VM2 is there, VM2, VM3, and so on, VMN. Okay, there are the number of virtual machines, and these virtual machines run in isolation. So, what is the benefit of this? So, this create more secure environment. How we can say that this create more secure environment? Because when these run in isolation, then if suppose any virus or worm, okay, any malware, if we can say, if any malware is attached with this VM1, okay, any malware, that may be virus, worm, Trojan horse, and number of logic bomb, number of malware is there. If any malware attached with this VM1, okay, that means that can corrupt the file of virtual machine 1, that can corrupt the applications, but this cannot create disturbance or this cannot affect nearby other virtual machine. Okay, so this worms or malware is isolated because this run in isolation, so that cannot disturb the other virtual machine. Other virtual machine work properly, that cannot disturb. So this is the beauty of this virtualization virtual machine. All these run in isolation. So vendor have to ensure that these virtual machine run in isolation. Okay. So virtualization is the simulation of software and or hardware on which this other software run, and this virtual or simulated environment is called virtual machine. Okay. For example, Windows and Linux both can run on the same laptop at the same time. Okay. And there is a number of virtualization software that are freely available in the market. Okay. You have to pay nothing. So for fun, you can install on your own laptop, like VMware. This is a virtualization software, okay, that create the virtual environment, means that enable you to run Windows and Linux both on the same host machine at the same time. So that create virtual environment, and this is free of cost available. Okay, for fun you can install and you can see that how the different operating system run simultaneously, and that is important. You need not to confuse that. Like somebody can say that this is not new because we can keep different operating system on our laptop or PC. Like we can keep the Windows, we can keep the Linux also on the same machine. But the question is that operating system can run also, but not at the same time. One time you can run Windows, or other time you can run, means you can boot your system with Linux. But beauty of this virtualization is that you can run these two at the same time. This is the beauty. Okay. So in computing, a virtual machine is the virtualization or emulation of a computer system. So virtual machines are based on computer architecture and provide functionality of a physical computer. Okay. Their implementation may involve specialized hardware, software, or combinations. So virtual machines differ and are organized by the function, just like in broadly we can say there is a type of system virtual machines, and there may be other type process virtual machine. Okay. What is the meaning of this one? So system virtual machine, also termed as full virtualization, that provide a substitute of a real machine. They provide functionality needed to execute entire operating systems, and a hypervisor uses native execution of share and manage hardware. Okay. The hypervisor is the name of virtualization software, that is also known as VMM, virtual machine monitor. Virtual machine monitor. Okay. So that is the hypervisor. So that hypervisor uses the native execution and share the hardwares and allowing the multiple environment which are isolated to each other. Okay. yet exist on the same physical machine. So, modern hypervisor use hardware assisted virtualization and the virtualization specific hardware primarily from the host CPUs, and the process machine are designed to execute computer programs in the platform independent environment. Okay. So, some virtual machine emulator, for example, or you can say this QEMU, other is video game console emulator. Okay. So, these are designed to emulate different system architecture, thus allowing the execution of software application and the operating system written for another CPU architecture. Okay. So, this emulation means, what is the meaning of emulation? No? Emulator or emulation. So, emulation or emulator means can create, okay, the code or that can run the applications, software that are written, that are designed for one kind of hardware. Okay. The software or application designed for one kind of hardware can also run on some other kind of hardware architecture. Okay. So, who facilitate this? That is the emulator. Okay. That emulate the environment of first kind of hardware for the second hardware, so that the application and software written for one kind of hardware like x86 that can run some other hardware architecture. Multiple operating system running on the single machine at the same time. Okay. Like this one, hardware, this is the virtual machine monitor, means this virtualization hardware, virtualization software, and there are different other operating system run on the same time, Windows, Linux, Mac, and that can deal different applications. So, this is the VM1, VM2 and VM3. Popular virtualization software that are available in the market, that VMware workstation, Zen, VirtualBox is there, Citrix, KVM. Okay. Let us see the history. So, first this virtualization name is first appeared in IBM mainframe in 1972. Okay. And that allow multiple users to share batch oriented system. And the formal definition of virtualization helped move it beyond IBM, like a VM provide an environment for the programs that is essentially identical to the original machine. Programs running within that environment, so only minor performance decrease. Okay. And then late 1990s, Intel CPU, that is the fast enough for researcher, okay, to try the virtualizing on the general purpose PCs, like in that 1990s Zen, VMware, okay, that means attract the different consumer and customer and client, okay, for this virtualization. Virtualization has expanded to many operating systems, CPUs and VM. So, VMware modern virtual machine system, and that is most of the cloud computing vendor, and the developer uses the VMware, okay, for the virtualization purpose. Founded in 1998, Mendel Rosenblum et al. And the research of Stanford University. Okay. VMware workstation, this is the other kind of virtualization software, and that separate host OS from the virtualization layer. Host OS may be Windows, Linux, etc., and a wide variety of guest operating system are available here, okay, for this VMware workstation. So, there is one important question, why we use this virtualization, what is the need? So, in reality we know that most of the server only use 5 to 15% of their capabilities on average, while consuming 60 to 90% of their peak power. The solution is virtualization. Use one server to host multiple applications, that reduce the energy consumption and that also reduce the CO2 emission, that means that save the environment. that is the environment friendly computing, green computing type of things that promote the green computing. So, running fewer highly utilized server frees up space and power. Less space and power is better for environment and save money. That means that save the money, save the effort, save the nature. So, these are the beauty of this particular virtualization. Okay. So, before virtualization and this concept or technologies, software developing, application monitoring, server management, network management, security management, data management, all these are have to manage differently. And now we have software as a service, platform as a service, and infra as a service, data as a service, and in fact everything as a service. This is possible due to this virtualization. And now let us see the virtualization architecture. Okay. So, basically virtualization, when we talk about the virtualization architecture, there are the two famous virtualization architecture. One is known as type 1, architecture, and other is the type 2 architecture. Okay. So, in general there are the three typical classes of VM architecture, okay, in which one is the hardware assisted, another is the software assisted. And when we talk about the virtualization architecture, so basically there are the two kind of architecture, okay, and that is the type 1 and type 2. So, let us see the before virtualization, we know that this is the image of our host machine. That means these are the different hardware. This is the guest means host operating system, and that run different applications. But after virtualization, these are the hardwares. This is the VMware virtualization layer and the VMware that create the virtual environment, and that create this virtual image of this particular hardware, like this one here. This is the virtual, this one, and that different guest operating system are running that can deal the different application. So, this is VM1, this is VM2. Virtualization architecture. Okay. So, a virtual machine is an isolated runtime environment, guest operating system and application. Multiple virtual system can run on a single physical system, okay, like this physical box, and this is the virtualization software, same number of guest operating system can run. So, they are the two famous architecture of this VMM. Okay. One is the bare metal architecture and other is the hosted architecture. That is very important. And in fact, this bare metal architecture is also known as type 1 architecture. Type 1 architecture, and this is known as type 2 architecture. Type 1 and type 2 architecture. So, let us see what is the type 1 and type 2 architecture. So, bare metal architecture, in this architecture type 1 hypervisor like VMM is installed on the bare hardware, okay, and VMM communicate directly with the system hardware rather than relying on a host operating system. So, basic is the main, this is suppose hardware, okay, and on the hardware there is a VMM virtualization software, okay, and then these number of guest operating system and application are running. This is the type 1. So, main difference is in type 1 host operating system does not play role in virtualization, okay, and in type 2 host operating system play important role, like here you can say the hardware, then hypervisor, then Bare metal means type 1, that means on the hardware hypervisor is seated and that create the environment. And in hosted architecture, this is the hardware, and this host operating system also play important role in virtualization. Okay, that means this hypervisor can manage these resources for their applications through this operating system, host operating system, and some other application can directly run on the host operating system. Okay. So, these are the two type of architecture. Okay. And example of this type one is the Zen, VMware, VMM by default. This is also known as OS independent VMM. And the type 2 architecture example is KVM, VMware Window Workstation, VirtualBox, and this is the VMM on demand and also known as OS dependent VM. Okay. So, thanks to all and Jai Hind.